All right, class. We're going to continue with vectors today. We're going to look at the addition method. Okay, so what happens is we were looking last time, you can have two vectors, right? You can follow one vector, so you follow one direction at a certain pace, and then distance. So you'd follow this direction here, and at the end of this, you would then make a turn in another vector. The resultant vector is if you made a straight beeline, right? You went from here to here directly. That is your resultant vector. What is the actual movement that you took? Okay, so let's just do another quick look at how to put two vectors together. So you travel 40 degrees north of east. So that's 40 degrees north of east for 5 miles. And we will go due north for 3 miles. My resultant vector would be right there. Okay, and then we will use law sines and cosines and all trigonometry to find out various things in this. But that is just drawing your vectors by vector addition. We're going 5 miles this way, 3 miles this way. This would be my resultant vector. No, you cannot use Pythagorean theorem here. It is not a right angle. Please don't make that mistake. Okay. So let's look at an example. So to reach this campsite over here, looks awesome. Hanging out, maybe fishing. You want to reach this, you're going to hike 2 miles at 40 degrees east of north. And then bang a right or due east for 3 miles. Okay. We want to know what is the magnitude. Magnitude, remember, is just length or speed, but in this case it'll be length, and direction of this hike from the starting point to the campsite. So that means if he were to, or she were to walk directly through the terrain to the campsite, at what direction would they have to go and for how long would they walk? Well, let's look at some things we may or may not have to set this up. I have my two sides. So typically when I have two sides, if I could find that included angle right here, right, if I could find this angle, I can use the law of cosines to find x, because I need this x right here. I also need, and I'll use a different color so we can follow it, I also need this theta to get the exact direction, right? That's the theta I'm going to be able to find, excuse me. Well, how can I find some information here? Let's see, can I find this angle using anything? Well, one, which may be a little more difficult, I might see that I have due east and east would be parallel, but, and then you can use parallel lines cut by a transversal, but I think we should just complete this right triangle right here. If that's 40, that's 50. If that's 50, by linear pairs, that is 130. So I can now find x by saying that x squared equals 2 squared plus 3 squared minus 2, 2, 3 cosine of 130. So I'm going to do this out. I'm going to get x squared equals 4 plus 9 is 13 minus 12 cosine of 130. So I'm going to take the cosine of 130 times 12. So I get x squared 13 minus negative 7.71. Remember, if you're subtracting a negative, we're going to add it. So it's 20.71. And I'm going to square root that. And I'm going to get x equals 4.55. So it asks for the distance to the nearest tenth. So that's 4.6 miles. We're going to still continue everything to the nearest hundredth, but this particular question does ask for the nearest tenth. So now I want to find this theta. If I find this theta, I can then find my direction off of east. Okay, so that gives me the sine of 130 over 4.55 equals a sine of theta over 3. So theta will be the inverse sine of 3 sine of 130 over 4.55. So theta, so let's take the sine of 130 times 3 divided by 4.55. I'm going to take that inverse sine of that, and I'm going to get 30.34. So this is 30.34. So this angle right here will be 30.34 plus 40, 70.34. Now you could say 70.34 east of north, right? You could do that. So I guess I would take that. So we got north 70.34 degrees east. Yeah, I think that would probably be the best one to do. We're going from north 70.34 of east. If we did it in another way, so we could also say it's 19.66 degrees north of east. Those are two ways, and you could just say 19.66, but we don't really use that one. Okay? So those are our answers. Okay, those are our answers. So the real direction is 70.34 degrees east of north, and you will travel 4.6 miles. Okay. I'm going to set this diagram up for you, and I want you to complete the answer using this diagram. Okay? So we have a kayaker leaves shore at 55 degrees east of north. So we're going to be going this way here. That's my 55 degrees east of north. And then there is a current that is pushing due east. That is at 1 mile. The speed here was at 3 miles. This will be my resultant vector. Okay? I need you to use that to solve out. Use this diagram and solve it out. We'll go over it in class. All right, so we have now set up and solved. You're going to solve this one. And I also want you to take this problem here and I want you to set it up and solve it. Okay, we will go over these in class. Good luck.